All right, for this lesson we're going to practice solving mixture problems. A mixture problem is very similar to what we were doing in the past with application problems for systems, but this time you have something and you mix it with something else to have a new something. So many times it's solutions or different types of candies like peanuts and M&Ms, but we're mixing them together to get a new mixture. The steps are very similar. You first have to identify what you know and identify the variables. Then you're going to translate it into two equations. This time it's usually the amount of the ingredient plus either the value of it or the percent to get the new ingredient. And again, you're solving by substitution or combination. This time, however, I am going to show you a new way to write out what you know and what you need to know. All right, take a second, pause the video, and read the problem. Okay, got it? So what we're looking for is the kilograms of raisins and the kilograms of nuts. So how many kilograms of each mixture must be used to make this new mixture? So I'm going to show you a different way of setting it up. Instead of let and let, I'm going to use a table. So I know that I'm going to be talking about raisins and nuts. And I know that I have this new mixture, so the new mix. New mix. And what we know about these is, or what we're looking for is how many kilograms. So the number of kilograms. And what we also know, or what we're going to be looking at, is the cost. All right, so the number of kilograms of raisins, we don't know what that is, so I'm going to have that as my X. And the number of kilograms of nuts, I don't know that, so that's going to be my Y. And the number of kilograms of the new mixture, we do know that, that's 100. And the cost, I know that the raisins cost $5.75 per kilogram. And I know the cost of the nuts is $4 per kilogram. And the new mixture has a cost of $4.70 per kilogram. And then I'm going to have this over here as my total column. The total. And it's really the total amount or the total cost. So if right here, the cost is $5.75 per kilogram and I have X number of kilograms, the total cost of the raisins was $5.75X. And same with the nuts. It was $4 per kilogram for Y, so for Y. And then this is the tricky part that people forget. The total of the new mix, right here we took the X times 575 to get the total cost. Here we took the Y times 4 to get the total cost of the nuts. So the new mix, we have to take the number of kilograms times this. So that is 100 times 470, which is $470. So if we bought all the new mix, the entire 100 kilograms, we would have to pay $470. From here, writing the system is extremely easy because it's going to be this column and this column. We have X, so the number of kilograms of the raisins plus the number of kilograms of the nuts equals the number of kilograms of the new mix. And we have the total cost of the raisins plus the total cost of the nuts equals the total cost of the new mixture. And this is your system. From here, you solve it like normal. So like in the last video, I'm going to pause and solve it on my own, and I want you to pause and solve it on your own and check back when you're finished. All right, hopefully you solved it without too many problems. Here's how I solved it. I used substitution again, so I subtracted X to get Y equals 100 minus X. I plugged this expression in for this Y right here, did the distributive property, combined like terms, used the inverse operations to solve, and I came up with x was 40. And then I plugged it in back up here in this equation that I solved. 100 minus x is 60, so y is 60. Then I put it back into my original equations, or I could have used the table. I do both. So 40 plus 60 is 100. So I did that there. And 575 times 40 plus 4 times 60 does give me my total cost of 470. So I know, and I wrote my answer over here because I was out of space, that there's 400 kilograms of raisins, 60 kilograms of nuts. All right, so let's look at another example with mixtures. This one is a little trickier because it's talking about percent of acid. So we're having solutions that have different acid amounts, and we're wanting to make a new solution. So I'm going to make my table. We are going to have the type of solution. We're going to have the weight in grams. So the number of grams. We're going to have the percent of acidity. And we're going to have our total. So by type, the only thing that we know, it's being called solution 1 and solution 2. So the first solution and the second solution and the new solution. And we don't know the number of grams. So the first solution, that's what we're looking for. How many grams of each? So the number of grams of the first solution is going to be my x. The number of grams for my second solution is going to be y. And I know that my new solution has 40. So the new solution has 40 grams. I know the percent of acid in each. The first solution, solution 1, has 40. I'm going to put a 0.4 for my percent though, so I don't forget to change it to a decimal. The second solution has 15% acid, so I'm going to change that to 0.15. And the new has a 25%, so 0.25. The total amount, the total acidity coming from solution 1, we remember have to take the number of grams times the acid because that's 0.4 for every gram. So 0.4x. The second solution, the total of acidity from that solution is 0.15y because it was 15% per gram, and we don't know how many grams we have. And the new, and again, this is the one that people forget. We took the x times the 0.4 to get the total. We took the y times the 0.15 to get the total. So we have to take the number of grams times the percent to get the total of that. So 0.25 times 40, so 1/4 of 40 is 10. And like my other table, and this is why I really like using tables for mixture problems, here are my equations. X plus y equals 40. And 0.4x plus 0.15y equals 10. And I'm going to use 10 again because 0.25 times 40 is 10. Here is my solution, and then you can decide how you want to solve it. So like we've done, please pause and then solve it and then check back in a moment. All right, so here's how I solved it. I decided since I have not solved by combination lately, I would solve this by combination by multiplying everything by, and I know that it's tough to read over there in the corner, negative 0.4, this equation. So I did negative 0.4 times x is negative 0.4x, negative 0.4 or 4/10 times y is negative 4/10 y, and 4/10 times 40 was negative 16. And then I did my combination, so I added them up. The x's canceled out. When I added my y's, I came up with negative 0.25y, and then negative 6. So y is 24 once I divided both sides by negative 0.25. I plugged it back in up here to get x is 16. I then did my check step. I could use the equations, but remember the equations just came from the table. So 16 plus 24 was 40, And 4/10 times 16 plus 0.15 times 24 did equal 10. So both equations checked out. So I had 16 grams of the first solution and 24 grams of the second solution.